The purpose of this video is a short introduction to concavity and points of inflection. You can see on the screen there is a polynomial function with probably some crazy equation. I think this one's degree 5, and it doesn't really matter what the equation is right now. The purpose of this equation is to illustrate some of the important features of concavity and points of inflection. And so we're talking not today about the minimums and the maximums. Like, we're not talking about this max here and this min here and so on. We're talking about something new. We're talking about points of inflection, which I'm going to show you for this particular graph. These three orange dots right here are points of inflection. So the first thing I need to teach you is why they're points of inflection. And one way to look at it is you kind of look on the graph and you kind of look at the slope. And if you look right through here, it kind of looks like the slope is momentarily linear. And there's more to it than that, but that's kind of a good starting point. The same here and here. Oh, and I forgot to put the names on. These are called points of inflection. And that's one way to look at it, but I'm going to show you a slightly different way. And what I'm going to do is I'm going to add a tangent line to the curve, and then I'm going to move that tangent line back and forth through the function. So now let's look at this section. If you look at all of the tangent lines before this first orange dot, and it doesn't again matter what the equations are, they're all above the curve. You see that? The purple line is on the top side of the curve. But now when I get to the point of inflection, you can see the purple line switches to being below the curve. And that is actually why it's a point of inflection. Above, below. And now I'm going to keep going, and you can see it kind of is straight there. Not exactly straight, but it's pretty close. Like if you look at the curve and you look at the tangent line, they're pretty close. But then you see it switches back to above. So here it was below, here it's above. That makes this point right here a point of inflection. And now we're going to continue. Again, there's another point of inflection there, and look, the curve switches back below. So overall, we have above, below, above, below. And that is what makes those three orange dots a point of inflection. So I'm going to move this out of the way. Just ignore that for now. And I'm actually going to switch the curve slightly so that it is a dotted line, because the next section, the concavity, will be easier to show with dotted lines. And we're going to talk about each section individually. Before the first point of inflection, between these two, and after the last one. So we're going to start with the first one. And you can see that the tangent line is above the curve. That's something called concave down. So I'm going to add a color in here, and I'm going to add a word, concave down. And another way to think about this is if you kind of imagine this red shape continuing, it would go like this and then continue down like this. It would be like a downward parabola. So that's another way of shaping it. It makes like a downward like curve shape, I guess. So that's why it's concave down. And also the tangent line is above the curve. Next section, concave up. It makes like an upward shape. Like if I was to continue this, it would probably go like this and like this. And additionally, the tangent line is below the curve. See that? It switched from above to below. That makes this section concave up. Now we're back above, making the next section concave down. And again, you can see the tangent line is above, and it's kind of like a downward U shape. And then in the final section, the tangent line goes back below, and it's kind of like an upward U shape. And that's really what we're interested in, the shape of the curve. Is the shape more of a downward shape or an upward shape? So now, just to finish this off, I'm actually going to hide the tangent line, because we don't need that anymore. And I'm actually going to hide the curve. And this is what we end up with. We end up with a polynomial function that's a series of downward shapes and upward shapes. And this is meant only to be an introduction. There's more to this lesson. This is just a starting point. Please, as always, let me know if you have any questions.